Okay, so this is the last section, and it's about transformations of functions. I'm going to go through this rather quickly in the slides because I suggest spending a bit more time on this on Hegarty Maths. There's many videos. Transforming functions means translating, reflecting, stretching, and so on. So, suppose we have some function called x squared. Sketch the function. Well, this is what it looks like. Why is the notation like this? Well, this helps express when I do transformations, and it makes things a bit easier. If I have the form like this, I don't have to write out what the algebraic expression actually is for it, because I might not know this one. We might just get told this is f of x, and then we might be asked to do some things. So over here, we're asked to do something. Compare the left-hand side and the right-hand side. So this is f of x. What is f of x plus 2? If inside you added 2 to every single x value, well, you would get x plus 2 squared. You would take the x from here, make it x plus 2, and then square it. You would get x plus 2 squared. What would this look like? Well, it would look like this. This may be a very obvious or a very unusual result, depending on how much you've studied this at GCSE. But we know from our previous work, we know that minus 2 is a root. More interestingly, what's happened is, as we've added on to the x, as we've added 2 on, it seems as though our graph has moved in the x direction, talking about left and right, by 2 units to the left. So we can express this more formally as, say, like a column vector, minus 2, 0. Or you could say translation 2 units to the left. And this fits part of sort of a wider pattern. So the way that this is often taught is about changes inside the function and changes outside the function. A change inside the function means it's sort of in these brackets here. The x's are affected, but not the whole thing necessarily. The change outside means this is normally occurring perhaps before the function part or maybe afterwards, but not in the brackets. This affects x and this affects y. And if you have a go with a table of values, you should be able to see why this happens. So we have x and y. And as we just saw, when we do changes inside the function, so for example, we just did f of x plus 2, it seemed to have the opposite effect to what we expected. If you look at the positive here, you might think, well, the right is the positive direction, so it actually moves to the left, which is the opposite. Whereas if you have changes outside, for example, if you have f of x plus 2, as you might expect, the whole thing moves up by 2. So this is kind of what you expect to happen. So this one here, inside or outside the function? It's inside. So something here is going to happen to the x. Minus 3, well, we actually kind of get the opposite of what we might expect. So this is going to go 3 units in the x direction to the right, or a translation. F of x, close bracket, then plus 4. This is outside. Plus 4 normally means shifting things up or translating by 4, 0, 4. So translations, these were shown by plus or minus. What about 5x now? What about a multiplication? So same question, inside the function or outside the function? Well, it's inside. Multiplying by 5, you might expect this to scale up by 5, to stretch by 5. But remember, inside the function, it's the opposite effect. So you are actually sort of shrinking it by a factor of 5 or stretching by a fifth more formally. And finally, this is what a stretch outside the function might look like. 2 is on the outside, 2f of x. So this is y direction. And as we expect, it stretches it in the y direction, scale factor 2. So these are some of the transformations you're expected to know. And you may need to do these with the sketch So for example, this sketch, you may need to move the sketch. That would be like a translation. Or you may need to do this with specific points. Say what happens to specific points. For example, the x-coordinate is reduced by 3. And in terms of sketching these, you can use basic versions and have a think. What's the transformation? So here, this is inside the function. To the x plus 1 has the opposite effect. So this shifts this to the left. This question here looks very, very complicated, but just compare. In fact, I would even encourage you to pause the video here and have a think. What's happening? Is the whole thing being affected, or is it the x's that are being affected? So hopefully there you can see, or you spotted, each x is being multiplied by 2. The minus 4 stays the same, so this is a clue that this is inside the function. Stretch by scale factor a half in the x direction. If something was 4 away, it becomes 2 away. If it was 6 away, it becomes 3 away, and so on and so on. Things get closer to the origin. Some other examples here. We could also talk, while we're at it, about reflections. Notice the negative at the front. So it's kind of like a scale factor of a minus 1 outside. This will reflect things. If you had a coordinate where the y value was 5 from before, minus f of x means minus 5. So I'll leave you to have a quick go at the questions there on the screen. So just pause the video. And I'm assuming that you've had a go at the video and at the questions now. So the opposite of a third is multiplying by 3 inside the function. So this is stretch scale factor 3. On this question, draw sort of a 1 over x or a 2 over x sketch. They look the same. And then we shift up by 1. So the key bit really is drawing the asymptote. Notice also that when you shift reciprocal graphs, you start to get intercepts. And this clears you to do questions in exercise 4E and F. But while we're at it, we're going to talk now not just about the whole graph, but what happens to specific points. So think of the points as x and y. Think of inside and outside the function, whether you need the x or the y direction, and hence does it affect the x or the y part. So inside the function, this is going to affect the x on this line here. All of these, the x is going to have some impact. Plus 1, well, what's the effect? It's the opposite of what you expect. So instead of adding 1, it takes away 1. So the x here is reduced by 1. The x is reduced by 1. The x is reduced by 1. Notice that the y stays constant each time. Same again. Next question. Inside or outside? So inside. In other words, this will affect, again, the x part, but not the y part. And it will do the opposite to what we expect. So 4-3 becomes 2-3. Instead of being scaled up by 2, the opposite is being scaled by a half. A half, 0, and 3 minus 4. So I'll leave you to think about the rest of the questions on here. Just pause the video. And revealing answers. So outside the function means affecting the y coordinate, multiplying by 3. So 4, 9, 1, 0. Okay, notice y is 0 already, so this point is invariant. 6 minus 12. Outside of the function, reduce the y by 1. Inside the function, multiply the x by 4. And these here, we actually have reflections again. So these are special cases. We looked at the last one already. it meant take your y and change the sign. So 3 to -3, -4 to 4, for example. For the x's, you actually just do the same. Sorry, for inside the function, you just do the same with the x's. So for these two here, the idea of inside, outside perhaps doesn't make quite as much sense. These ones are reflections. So you need to be able to talk about what happens to the graph and specific points as well. And this final question is a good test for you to sort of see if you've got the key ideas. However, I will leave the answers for this one, as you may be doing this question in class. And you should now be able to have a go at up to 4G and any of the questions in the exercise.